Alrighty, so it's clock, so we'll go ahead and get started. So hello and welcome to the last session for Shulk Ignite, session 8. This is for Scorch, and so today we're going to be talking basically about security. So this is going to be kind of some of the stuff that we're going to cover. And if you don't have the exercise files, just go ahead and download them. There's been no changes, so you don't have to update them if you already have them. And the slides will be available on the website as always. So to recap, last time we talked about backends. So I apologize, it was a little bit rushed at the end there for the Flask stuff. But now that we actually have the idea of like what a backend is, how it does some data processing, how all that stuff kind of works, how do we actually make something that's safe as a backend? How do we actually make sure that something doesn't, give away everybody's details whenever you try and log into it? And so first off, we'll start with just a question, just as a review. Let me just quickly pop up in Top Hat. And I'll go ahead and assign that one in Top Hat. So yes, the question is, what does the following code do? Here's the code snippet. And then I'll go ahead and just start the question. There is your options. So I'll give you guys a chance to answer that one. Okay. So for this one, let me go ahead and end this one up. So this one is going to be B. So the answer to this one is it creates a Flask app that has one route, which is the homepage, and just returns a string. So this slash here is going to be the route, and that's just going to be the main homepage there. And then that's just going to go ahead and return the string we can see down here, which is hello world. And so that's what will get returned to the browser. Okay. And so now, what we're going to do today is we're going to be focusing on how to keep your sites safe. So kind of ideas about how some sort of attacks work and how this stuff operates and how people might attack your sites. The idea is that we understand how to do these things so that we can actually prevent them from happening. So just like Laser Quest, where you got to go in, you got to see the giant board of rules and you got to approve and then say you're going to follow them. This is basically what we're doing here. So what we're covering today, you will not use anything that we're talking about is breaking into websites that you don't own. You will not use any of these things to take anybody's personal information with any ways that we're talking about. And you'll not use anything we're talking about to shut down people's websites, even if they break up with you. So especially if they break up with you, you're especially not allowed to do this to your access. All right. So that's just some ground rules for today. So just make sure that you're following those. And although I am kind of joking about this, just keep in mind that there are laws around these things now. It used to be kind of more of a joke back in the early 2000s of whatever, you can DDoS each other's websites and nothing can go wrong. Lots of these things are now crimes because there's other companies involved and stuff like that, and they will happily sue you on behalf of somebody else. So just be careful with any of these things. Really don't screw around unless you know what you're doing, and make sure that you have permission from people before you try and break into their websites. And yeah, you got to have at least one cool set of sunglasses and trench coat as well. That's the requirement as well. Okay, so different motives for attacks. So a lot of people kind of just think that a lot of attacks that you're going to have are just, there's going to be one thing they're trying to do. They're just trying to shut down your website. This is not true. There's a ton of different types of attacks and different ways of doing these attacks. So some people might be there to just stop you from operating. So other companies might, for example, try and shut down another company from operating in order to be able to make more money. People might try to steal your data. So ransomware and stuff like that is a very popular thing that happens a lot. They might be there to steal other people's data, so data that's stored on your servers and on your websites. They might just want to get access to your systems just so they can be able to do stuff down the road. This happens a lot in games. If you do end up running a game server, just be aware that you will constantly have people trying to hack and give themselves a bunch of gold and stuff like that. So just be aware of that. And some people will also do this to gain access to other people's systems. So if your system is inside somebody else's system, they might be getting access to your system in order to get access to somebody else's system, which is a bit of a weird roundabout way of doing it. Or they might just be doing it to screw with you. Not everybody listens to my laser tag style guideline rules, and they might just be there to screw with you. So just keep that in mind. And not all attacks are created equal. So keep in mind, even if you are doing scans and stuff like that to check to make sure that things aren't happening, some people will leave vulnerabilities in place and leave their sort of stuff running on your server for months at a time, and they won't do anything. And then months later, after they've already been inside your server, they'll start doing stuff. So just keep that in mind. The best thing is to be proactive about your security. Don't wait until after something happens to try and solve a problem. Make sure to be looking for these problems consistently and be testing out your websites and stuff, especially if you're going to later on in life, if you're going to be doing this for money. Okay, so the first thing I want to cover is what's called fake security practices. And so there are tons of things that people will do to secure their sites that are basically worthless. They're essentially just, they might be there to make them feel better, but they don't actually do anything. So one example of this is security through obscurity. So you can see here that this says secret text, right? It looks really secure. And if you go ahead and you highlight it, Oh, it's white on white text. Nobody would have seen that one coming. This sounds stupid, but there are people who have done stuff like this. I have seen people who have legitimately left encryption codes in the comments of an HTML website before. I've seen people who've done things like they'll leave like a hidden field on a form, and that hidden field would contain somebody's password. Sadly, I saw this with a government website that I won't be mentioning today, specifically which one, but this did actually happen with one of those where people's SIN numbers were actually available in the HTML. This stuff is really bad idea. Just because people don't see it doesn't mean it's not there. If you're sending HTML to people, they can find it out from there. And anybody who is involved, like anybody who's submitting information to you, is trusting you to keep things safe. Don't do this. This is a bad idea. All right. I remember actually one of my instructors for an operating systems course also told me about there was a router, and the way that the router worked was they would send essentially a signal, and that signal was just based on the amount of time it took for a message to come through. And you could actually get into the router by just sending a bunch of ones at it in a certain timing pattern. And so people would just break into like enterprise grade routers by just sending a bunch of ones. So this sort of stuff is just a terrible idea. Somebody will eventually figure out what you're doing, and then they'll take whatever you have there. So just don't do this. So yeah, a good example of this is like, imagine you're in a foreign country and you're a spy and you don't want other people to know what you're saying. So instead you just release all of your government secrets in Spanish and just hope that nobody there speaks Spanish, right? This is basically the same idea of obscurity, security through obscurity. You're essentially just kind of hoping on against the odds that people won't figure out what you're doing. So just don't do that. So there's some good examples of this. So access by location. So sometimes people will set up systems where you can only access it when you're in a certain place or a certain time. These ones, there's always ways of circumventing these. So be careful. GPS is at the end of the day just a normal system. So somebody can fake a GPS location. Somebody can also fake their time. Complexity. Some people will just make it, really annoying. So there might be something like the same word used 10 times over as a password. It's a great pattern because it's really long and it's really hard to break, but eventually if somebody figures out that you're just using the same word 10 times, they can just copy paste it. So really easy to get it. Shared keys and passwords. This is just a bad idea in general. Even if you make your password like complex, don't share it with other people. The second you share it, as far as you're concerned, you should consider it to be compromised. And then fake outs. So things like people will, and yes, this is a real thing, people will put up intentionally insecure versions of their server with fake information, hope that people will break into them, but not actually break into a real server. I've seen this happen. It's a really dumb idea. Don't do this either. Honeypotting is a different thing. You can look that up afterwards if you're interested. That is a real security practice, but doing this, like having fake versions of your app that people can break into, is a stupid idea. So just don't do this either. So here's an example in the real world of what this might look like. So you might have something like this where somebody will have some JavaScript that has the password directly in the JavaScript. So like the password to whatever like server they're using is directly in the JavaScript. They'll then have a function that does something, and what they'll do is they'll run it through what's called an obfuscator. And an obfuscator will basically take the code and it'll run it through and it'll make it look like this at the end, right? And so you can see here, wow, this is like, you can't, like you're not gonna be able to figure out what the secret key is from this stuff at the end, right? Well, some obfuscators are better than others, but this one especially is really bad. This is the first one that I found because, as you can see down here, actually the encoding for the password is just right down here. It's just using a different name. And there are a ton of other things that will do exactly this sort of thing. So you do not want to use obfuscation to try and hide your passwords. Just don't put them in JavaScript, basically. Do all this stuff on the server. Yeah, you can reverse obfuscation. There's tools online to do it. And if people know what settings you're using, they can do it immediately. They don't even have to use any processing power. But even if you don't know what settings are being used, oftentimes you can reverse obfuscation as well. So just keep that in mind. Yeah, it's basically like using a fancy security system and then leaving the key under the door. It's like, under the mats at the front. It's like, the security system is great and it probably works really well. But if you just have the key under the door, then people can just open the security system anyway, so it doesn't really matter. And one other thing to mention is just in general, your front end should not be relied on for your security in any way, shape, or form. As far as you're concerned, you should always consider the front end to be compromised, especially when you're dealing with the back end stuff. So whenever you're processing code in the back end, you should assume that your front end is going to give you bad information. This is because anything that happens on the front end can be manipulated by the user. Literally anything that happens can be manipulated by the user. And I want to show you a good example of this with Microsoft. So Microsoft originally had a Copilot demo that was existing where people would have to sign up and they'd have to go through an NDA in order to get access to it. The problem is the way they secured it was they just added a disabled flag. So people could go in, inspect the element, delete the disabled flag, and then hit enter. And then they would just press the button. And now you have access to the thing without having to sign the NDA. This was a real thing that happened earlier this year. So don't rely on JavaScript, don't rely on your HTML, don't rely on anything like that to keep your system secure. It will not do it for you. So just be careful. Yeah, this happens a lot where people will have like a form that requires a valid email to come in, and they have something like a formatter that basically will force it to be an email that comes in, right? By the time that it reaches the backend, somebody could have inspected the element, removed the validation, and then submitted something that isn't an email to that system. People actually used to do this intentionally to servers years ago, and the reason that they would do it is because then when people were trying to fire off a bunch of emails, the emails would all be invalid, and it would shut down the person's account on whatever server system they were using. So people used to do this all the time, where they would delete the email entry, the validation stuff, and then send a bunch of fake emails that would never work, so that they would rack up a bunch of errors, and then they'd be flagged as being a spam bot, essentially. So basically what you should do in that case is when the form comes in, when you get the data into your backend, you should then do the validation checks again on the backend. The front end validation should be to make sure the user is able to enter stuff more easily. It should not be actual security. Just keep that in mind. And there are times that front-end security does actually matter. So when I say it doesn't matter, what I mean is that it's not an actual thing to secure you as the developer. It's not there to keep you safe. That's not what front-end security is for. What front-end security is for is that when there is things that are passed from you to the front end, you should make sure that those things are safe. So things like cross-site scripting is going to be something that we're going to talk about. But all of these sort of category of things typically fall under the idea that all user input is evil. Anytime that anybody's able to put anything into your system, consider it to be probably evil. And usually it will end up being at some point. This is where most of your vulnerabilities are going to come from, and this is where the most complicated vulnerabilities are going to come from as well. So cross-site scripting is the main thing. You may have heard of this before, XSS, a whole bunch of different other fancy names for it. All that it means is that essentially you can have people inject code into sites that then runs somewhere else. So if they, for example, might have something like a like on Reddit, for example, like you might have something where you can like make a post on Reddit. Somebody might include some HTML or some JavaScript in that post and then submit it. And if Reddit were to read it as JavaScript or as HTML and whatever and run it, then essentially that code is being run on your server without you, or your device without you being aware of it. And so that sort of stuff happens all the time. And there's lots of complicated ways that it happens, but there's also lots of really stupidly simple ways that it happens that you could easily avoid. And so the best way to deal with this is through data sanitization. Like I said before, you should consider all of your input to basically just be evil. Anything that's coming in from any users should just be considered to be probably bad by default, and you should be cleaning it before it actually makes it to your backend and before you're doing any of the processing, and especially before you're going to show it to other users. So we saw this example in a previous session, and I'm going to go through and explain it again. But this is basically like a system where you can like create pages via a editor where you can like write out a page, and then you can have it be created into like another HTML page. The way this works is we've actually used this before, this functionality, super handy, but in JavaScript or on any HTML elements rather, you'll typically have these on-click things where you can run JavaScript as a function, right? You can have a function inside of here, and then we hit on-click. Whenever somebody clicks the elements, they'll actually get the function, will actually activate, right? You can actually just skip the function call and just write the JS directly. So you don't have to have a predefined function for this to work. You can write one inline like this. So alert basically creates a pop-up that shows up for somebody, and then they can click it, right? So in this case, we can say on click, somebody, it does this. So if you have a button, for example, that's supposed to be like a login button, for example, you might have somebody who will put up like an alert where somebody can then enter in their information, and it might say something like, oh, sorry, there was an error with your password. Please enter your password again, and then hit enter. And people could then put this onto, again, something like Reddit. Whoever types that password in, it might get sent to another server, right? So something like, and so something like that might happen if you allow people to do this on elements, and it's really hard to like avoid this problem because there's a lot of ways that people can inject JavaScript. The worst ones for this is actually elements that have no user interaction. So at least for the on click, somebody has to click it. There's also things like on hover, which technically still needs user interaction. Somebody has to hover over the elements to have the problem happen. But there's other ones as well that are really dangerous, like, for example, on error. So on error happens whenever the element throws an error. And you can force elements to error out, which means that basically the second the HTML loads, the user has no choice. Immediately the JavaScript gets run the second they hit the page. This is how a lot of like, this actually causes a lot of problems. This is going to be one that I'm going to talk about later with TweetDeck. And this is actually how this problem occurred for them. So in this case, you can see down here, we have some HTML where we have image, and then the source, we have a hash. And hash links can be used in HTML in order to indicate like a place on a page. So you can basically put like hash and then put it in an ID. And then when somebody clicks it, it'll take them to wherever the element is with that ID. It's a really handy feature, but a blank hash is technically a valid URL, but it technically throws an error if there's nothing after the information because it's trying to select something from the, trying to select an ID that doesn't exist. So what happens is that this will always throw an error, and you can then tell it when it errors to do something else. So this means that no matter what, if somebody loaded this page, they would get this alert immediately the second that it happened. Likewise, if they had some JavaScript in here that was, for example, scraping their password and then sending it to a server somewhere else, this would immediately run without them knowing it and having no option to stop it from happening, essentially. And so, yeah, so imagine that you have a social media profile where, for example, you could include HTML so that people could kind of see what your page looks like, customize it, and it could kind of look cool, right? They can then run JavaScript to make it a little bit more dynamic, and then you can kind of send and receive any data from external sources. This isn't a hypothetical. This is what happened with MySpace. I'm guessing nobody in here actually used MySpace because I think it was even before my time. But MySpace was basically a social media platform that existed in the early 2000s, and it would do exactly this. You could put in HTML in there, and one of the most famous attacks that happened is what's called the SAMI worm. And the SAMI worm actually itself was not very complicated. All that it was just some JavaScript. And what it would do is when you click on Sammy's profile, it would go through, and with JavaScript, it would add Sammy as a friend. And then from there, it would post on your wall, most of all, Sammy is my hero. That's what this would do. That's what the JavaScript would do. It would then post the same post on your wall and then send a message to all your friends to check out your wall. This ended up hitting millions of people in a day, basically, essentially. And while this is kind of funny and it's kind of harmless as far as like the actual problem went, I think Sammy ended up with like 3 million friend requests, something like that, or something ridiculous. And it sounds kind of ridiculous. He did end up getting charged $20,000, and he was banned from using any internet devices for 3 years, under watch of like the FBI, essentially. So although this is kind of funny and it's like kind of harmless, it does have real world consequences. So just keep that in mind when you're looking at these things, to just be careful when you're going through it. But that's all it was just some JavaScript that he put on a page, and that's it. It basically just infected millions of people in this case. TweetDeck is another platform that I had talked about earlier. TweetDeck was basically a system for people to be able to, who had multiple Twitter accounts, to be able to manage their Twitter accounts. It was actually bought by Twitter at some point. TweetDeck was allowing you to have unsanitized HTML and JavaScript in tweets. What this meant is that people could tweet and a link like I showed you before with the image where it would throw an error, and the people were using that to collect people's advertising information and using it to click on different things on the page. So as you saw before, with any elements on a page, you could do documents.getElements, and then you can manipulate elements. It was doing things like, for example, sending people information from people's pages. It was sending people a list of their friends. It was sending people their private information, sending them their emails, their whatever, the last 4 digits of their credit card, stuff like that. And this was all because TweetDeck itself was essentially just allowing any sort of JavaScript to be executed at that point, because anything can run within, that would fit within 140 characters. So details can be found there if you're interested in how that happened, but that's basically the gist of it, is that somebody had the image thing, they put in a broken source, and then they said on error, run my JavaScript. That was it. And that cost them the company, multi-million-dollar company, and it crashed and burned overnight with lawsuits. So okay, so what's the actual, so how do we actually solve this problem? Because now we know what the problem is. How do we actually stop it? So you basically need what's called sanitization. So there's a couple different options. For HTML, there's some for NPM and a couple of other options. There's also an article that I've linked down here that includes information about how to do this. But basically, you want to find somebody else's sanitizer and use that. DOM Purify is a good option. HTML Sanitize. I've linked all these different ones in here. Basically, what they'll do is they'll go through and they'll check to make sure that everything is safe before it runs. But you want to use somebody's sanitizer before you let anything like this be able to be stored on your server. Okay, so that was all front-end stuff that we talked about so far. Like everything that we talked about so far, basically front-end problems. Things that we're going to focus on now are going to be back-end problems. So what are things that happen after you receive data that you can possibly cause problems with? Now, these issues might actually present themselves in the front end, but the issue should be solved at the back-end level, is basically what we're going to be looking at for the rest of the time, which is how you should be solving even the problems we've seen so far. So yeah, a lot of your pages that you're going to be using, any systems you're going to be using, are going to use some sort of a templating language, or they're going to use some sort of a framework or something like that. Even if you look at different frameworks down the road, they'll use something in order to generate your HTML. All of these things mean that they're going to get executed at some point, and they're eventually going to get sent down as HTML. So these will be relevant for literally no matter what system you're using. So here's an example where we have somebody is able to this, like we can display some content that somebody's wrote. So maybe it's like a blog post or something like that, right? We have post and then we have a post ID. And then from that post ID, we're going to get content. And this get content is going to go and it's going to grab some stuff from somewhere else. So it's going to go through, it's going to go grab like a template. It's going to go grab information from the database. It's going to return that information. And then you can render the template as a string, right? So that's all it's going to do. So basically it's going to go grab the information, pull it back that somebody has already submitted. Now imagine that somebody put something in the template, like for example, user.name. So let's say, so we can see here where we have these brackets is where we can include variables. So what happens if in those variables we included something like user.name, where the user object is something that exists in Python and it has the person's name there, right? If you went to this post ID and you did that where you had user.name, for example, it would then show up as a variable. So if somebody had a variable in there, user.name, it would show up like whatever their name is. In my case, it would be Kieran, for example, if I had an account on this website. So now what happens if we injected some code by making a post on the page and then asking it to have JavaScript that would send that information to a server? So this would be the comments. This would be the text of the comment that you would include. And you'd make this like a blog post on the page. This you can see here, we've created a div that has some sort of an ID, which contains the user's password, right? So essentially when this renders out, whoever the user is who's currently viewing this, their password would get filled in here. From there, we then grab that password and then we send it to a server somewhere. That's basically how something like this is sort of an attack would work. So grab the user's information based on the information that's available in the backend, and then chuck it into here and submit that information back to somewhere else that you want to keep the information at. So you could do a lazy way of doing this in Python would be to just go through and replace all of the information so that none of that works. So you could, for example, replace the brackets. So anytime that somebody tries to put squiggly brackets in, it just wouldn't work. It would just get replaced with nothing. So that everybody's squiggly brackets would get deleted. You can get rid of functions, get rid of script tags, get rid of angle brackets, right? This is kind of like we can just get rid of a whole bunch of the stuff that's problematic, right? The problem with this is that we are assuming that we know exactly what every possible problem would be in this case, and we don't. There could be a ton of other things that are going on that could be a problem with this. And so you would want to make sure that you're doing this in a more safe way. Flask in particular, which is what we're going to be using today, that's what we used last time, will actually filter out this problem by default. Lots of frameworks that exist today will do this, but if you're going to be using newer frameworks, a lot of them don't necessarily do these checks. And so I've actually created in all the stuff that we're going to be using, I've created a custom filter that will allow these sorts of errors to happen. So you're going to go through later today, and when we have the exercises, you're going to be securing the systems against these vulnerabilities. This filter that I've added will reverse the safety things that have been put in place, and then it'll be your job to write the safety from scratch, essentially, is what we're going to do later on today. Okay, so how could we actually approach this problem? Well, one of them is that there's two ways of looking at this. So the way that we looked at before, where we're removing the stuff that we think is going to be bad, is what's called a blacklist or a deny list. So essentially the idea is we specify what's not allowed and then everything else we allow in. So we basically say every other type of text is fine except these types of text, and then we're just going to get rid of those, right? What we can also do is a whitelist, which is where we say these types of things are allowed and nothing else is allowed. So we could use this, for example, to say, maybe for like the Reddit example or for like any of the other ones that that are an example that we saw previously, we could just block certain elements. So we could say, hey, you're not allowed to use image elements. Hey, you're not allowed to specify a source. Hey, you're not allowed to do this. You're not allowed to do that. We could just add these things. We could just refuse to add these things to the whitelist, and then that way all of them would be blocked by default. So whitelists will tend to overcorrect, and blacklists will tend to undercorrect. So depending on what system you're using, will depend on which one you want to use. So yeah, blacklist is basically when you have a few things to keep out, but most of the content's going to be fine. Whitelist, when you have a bunch of stuff and you have no idea what stuff is going to be fine unless you test it individually. So looking at our code that we had before, something like beautiful soup, this code is in the speaker's notes if you want to copy this later. This is basically going to sanitize our HTML for us, where we give it a list of tags that we're going to allow, and beautiful soup will go through and it will delete any other tags that it finds in the HTML. So when the HTML gets to us, it'll delete everything else except for strongs, EMs, paragraph tags, ULs, LIs, and breaks. Those are the only ones that are going to be allowed, essentially. Okay. So we've now seen two options for ways of doing this, but this exercise, what we're going to do is I'll actually show you what this looks like. So when we're taking a look at this page right here, You can see here we have a comment section. And when we're looking at these comment sections, we can see here that we can add some formatting. So we can add in some HTML to search and formatting so we can have stuff like this show up, right? You can see down here, we have some other stuff where it says, I got your password. Here's the password. If you want it back, send me $20 to my PayPal. Okay. The way this is working under the hood, if we actually take a look at these comments, I'll just go ahead and show the code. So inside the comment system here, if you take a look at the routes, we can see here, this is what the text looks like. So we got your password, user.password, right? So this person actually doesn't have their password yet, but they're pretending they are in order to get them to send them money, which is also a thing that happens pretty often where they're not actually able to get the content out from somewhere, but they'll try and blackmail people into giving them their information, right? Same thing here we can see where we're saying, hey, for current user in users. So look at every user that's available on the app, get their username and then get their password. And that's what this comment down here is doing right here. Where we can see here, hey, here's all the people that we have. We have John Doe and that's their password. We have Jane Doe with their password, this person's password, and this person's password down here, right? So what you're going to do is you're going to take this system, and the way that it works is there should be, I believe there's a to-do. If I go ahead and just search for it, it should be a to-do down here. Yep. So right here is where the actual stuff is being passed in. You're going to have to pre-process the comment and make sure that the comment is safe before you display it to the users. And so the way you can test this is when you have a terminal open inside the comment system folder here, you're just going to do Python and then routes.py, and then that will run the server. And then with the server running, you can go ahead and just check whether or not these passwords show up down here. They should show up as plain text as opposed to the actual password itself. So you can go through and check and see if any of this stuff worked afterwards, but you're going to basically make sure that this stuff isn't giving them the actual passwords. So we're going to give you guys a chance to try that out. Okay. So if it worked for you, so this is kind of like what it looked like by default, where you have the password showing up in here. This is one option, one way that it could end up looking, where you have something like user.password in this case. In this case, all that I did was just remove the brackets. So in my actual code, I'll just show you what it kind of looks like. I'm trying to remember. Not this one, that's the original. This one, there we go. So all that I did was the comment itself. I put in sanitize HTML, which is a function. If we go to that, it's just doing that replacement stuff that I was talking about before, where it basically does all the replacement and then spits it back out. So essentially each of the comments that's going in is being stripped out. So all the bad information is getting removed from it. This solution is fine. This does somewhat work, but what I would recommend is having this here. And also what you want to do is whenever somebody submits a comment, you would also want to have it be cleaned out before it actually shows up. So in here, you'd want to make sure that you sanitize the information before it even gets to your system, because defending against bad information, just storing the bad information in your database isn't really a good solution, because you're just begging for problems down the road where somebody accidentally forgets to keep the sanitization stuff working. So making sure that you actually have the information stored safely as well is a good way of doing it. So I would recommend also putting it on whenever the actual comments get sent in. You also make sure that stuff works. And then if you already have an existing log of a whole bunch of comments, going through and checking for all the information about the passwords, for example. So all these comments, going through and just scraping through, making sure they're all clean, and then also making sure you have those safety places in check, because then you have 3 points of failure as opposed to 1, and then you just avoid more problems down the road. Okay, so going back to the slides. Okay, so yeah, Beautiful Soup 4, we talked about that. That was in the previous slide with the code that was there, but basically it's just a system for in Python being able to do same sort of work that we were talking about before, doing the sanitization work and making sure that stuff works properly. Okay, so why is the code that we just wrote using Beautiful Soup actually better than just doing a find and replace, right? One of the reasons why sanitization with a proper system is better than trying to do this find and replace stuff is that sometimes you do actually want other features to exist. You can't nobody's going to use, for example, Reddit if you're not even able to bold text or show italicized text or something like that, right? Nobody's going to be super happy with that. So you want to enable some features, but you do want to also keep the site safe. And so this code with something like Beautiful Soup is a little bit more nuanced than using just a plain old, delete everything that shows up if it has a HTML comment in it. And so regular code is one thing, So having sort of like the being able to get variables, being able to like execute functions in Python, stuff like that is one thing that you need to be worried about. But you also need to be careful when you're processing your data, how you're doing your process data, because you can also find other vulnerabilities with other parts of your system as well. One of the main one being what's called SQL or Squeal, if you want to have the fun version of the name. But essentially what SQL does, or SQL, or whatever you want to call it, is it's basically a way of talking to databases. And it's a very common way that people will talk to databases. And it's its own kind of like language where you basically define that you want to select, I want to select the user name, or sorry, I want to select name from the table called users, for example. And there'll be a bunch of these like tables. They're kind of like, you can imagine them kind of like spreadsheets almost, that'll have columns with information in them. So there might be like a user table where there'll be a column called name, column called password, column called email, column called whatever. And you'd say select name from user, right? And then that might be where you get all the names for all the users in your system. And so, yes, you have rows, columns, tables. Essentially, it's just an Excel spreadsheet. So looking at a visualization, it would be kind of something like this is what you could imagine, right? So the file might be called users in this case, right? And you might do select name from users. Or in this case, where you have products, you might do select cost from products. And that would return all of the products in that case. You can also do filters and stuff like that, where you might say, select users where age is greater than 4, or like select products where cost is less than $50. This might be something, for example, if you're doing a search bar on a website, something like this might happen where you have a string that you're basically building, and it would look something like this, where you say select attributes from some table. So you might say select price from users select price from products where product is less than $10, for example, right? And those fields would be filled in by whatever the person selects on the page. So they might go ahead and they might select something like, for example, I want to find all the things on Amazon that are less than $100. I have $100 to spend. I don't want to spend more than $100. Only start with me stuff that's less than or equal to $100, right? And so the problem is that because this is just a string, you can add extra things to the string. And so one thing that's I think there's more information about SQL here if you're interested. But one thing that you could do, for example, is let's say you have something where you have a search bar and you're selecting a certain product based on its ID. So people will get like IDs, they'll put in those IDs, and then that's how they search for a product, right? What you could do, the query is going to get replaced by whatever somebody types in to the search bar and then it hits enter, right? And so the way SQL works is you have a statement and then you have a semicolon, and you can put multiple statements in one section, right? So let's say, for example, you do something like this, where you say 1, and then you end the string, and then you say select password from whatever, right? What this does is basically it's going to go through and it's going to replace where ID equals 2, and then it's going to have a 1 here. It's going to end that, and then it's going to execute the next statement, which will be select password from users, which is the bad statement that we don't want to have to deal with. And then we're going to say select star from products where ID equals, and then there's a little colon thing there, right? What this will do is first, it's going to execute the ID equals 1. So it's going to find a product that has an ID equal to 1. It's then going to get the password from users, and then it's going to error. And what it'll do is it'll just return this information on most systems. So it'll only execute the second statement here, and then it'll return that second statement, and then it'll error out on the third statement, essentially. And so this is a way that you could basically have somebody give you all of your users' passwords, which is not great. You don't really want to do that. And so this is where you want to be really careful whenever you're doing like search bars and stuff, not to just dump whatever they respond with into the system. So yeah, so this is what it becomes, right? So select star from products where ID is equal to 1, and then select a password from users, and then select star from products where ID equals nothing at the end, right? And so that's essentially what we're doing with that last statement that we did. And so we'll get all the passwords from the system, as well as we'll get the products that have an ID of 1, which is just a garbage request that you just have to finish off just so that you can end that request, essentially. And so this is where there's a joke called old Bobby drop tables. This is from XKCD, but basically the joke is like, why did you name your son Robert : drop tables? There's a command in SQL called drop tables, which is basically the same thing as saying delete. And so the joke is that like, whenever you have a kid that has this name, basically it's going to delete your system, essentially is what's going to happen. And something like this, I forget, but one thing that you'll run into is you can never guarantee that even safe input is going to be safe necessarily. So even if you have somebody who is like a secretary or something that's working at a school, they might not know anything about SQL, but most of them probably won't. And so you might have names that might actually be something in a programming language. You might have like names, for example, where they might have a certain command that shows up in a SQL language, for example. You might have something like, well, I can't think of an example off the top of my head, but there are names that you can have that will cause problems. One other one that I've seen is somebody bought a license plate, and the license plate was called null, and that actually registered in a system as null. And what that meant is that anytime that anybody assigned a parking ticket and forgot to put the person's name in, they got the parking ticket. And so I think they were in San Francisco, and I think they ended up racking up about $30,000 worth of parking tickets because they didn't have a name as far as like the license plate goes. And so anytime that a ticket came in, didn't have a name properly inputted or the name errored or something like that, they would get the ticket. So, you can run into problems. So here's another one, for example. So a lot of, this happens a lot with license plates, actually. Somebody has just taped some stuff on the end here where they've essentially said, okay, here's their actual license plate. And then they've said, drop database table. So in this case, what they're saying is delete the parking ticket table. So if they're speeding through somewhere, it's going to add their license plate as a ticket for $0 and then drop the table. So delete everybody else's parking tickets is basically what this says. Again, don't do this. I'm showing you this because it's kind of funny. Don't do this in real life. If you do this in real life, there's a good chance you will just be charged for it. The police don't find this very funny. So don't actually do this, but some people have done it in the past. So I'm just showing you kind of what it could look like and what you might expect if you do run into real systems down the road. One way to mitigate this as well is what's called an ORM. There's a bunch of fancy ones you can look at. For Python, SQL, Alchemy is one of them, and there's a couple of other ones. What they do is you create Python objects, and then those Python objects will generate the code you need. And so what that means is when you pass it, for example, like a search query, that previous search query that you sent won't work because the ORM itself will handle the actual sanitization of the information, and then it will generate SQL in the backend to send off. So these can be super handy, especially when you're first getting started. I would still recommend learning how to do SQL sanitization, but these can be super handy off the bat. Okay, so now we've talked about SQL. That was a little bit harder to understand until you could know a little bit more about SQL, but there is one that's pretty common, which is files. And files should scare you always. Just permanently be afraid of files. Every time you open up your desktop, just be afraid of them. No, but if you are making a website, be very careful if you are accepting other people's files. There's a lot of stuff that you can do that can just destroy your whole system if you're taking in people's files. So not just receiving files from people, but also how you create them can impact a lot of your security. So this is what's called path expansion. This is a very common, again, a lot of these attacks are kind of old school, but they do sometimes still work. So you've got to be really careful with whatever systems you're using to make sure that you're safe against them. Essentially what you do is sometimes people had a great idea. Okay, I'm going to let my user upload a file and I'm going to let them pick the name. So whenever they upload a file, I'll let them pick the name. Whatever name they pick is what I'll use on my side. So on my system, I'll use whatever name they say, and then that'll be fine, right? This is a terrible idea. Again, this is user input, and so you're going to run into problems. One of those being, let's say, for example, you had a file structure like this. So you had a folder called project, you had static, you had some user uploads, and then images, templates, whatever, right? So the idea is whenever somebody uploads a file, you're going to by default put it inside this user uploads file, right? You're going to just chuck everything in there, essentially, right? So here's your backend code. So whenever they put in a path, they'll type in whatever file name they want. And then from there, that'll be what you'll use as the file name, right? Sounds good. Cool. So here's the problem. When you are messing around with a terminal, you can actually see this whenever you open a terminal and use it yourself. You can go back. So you can see here, when I'm inside this folder right here, let me actually make this bigger so it's easier to see. So I'm inside a folder here. If I go ahead, I type cd and then ... What it's going to do is it's going to go, I was originally in a folder called file comment system inside of a folder called exercises. I'm now inside the exercises folder. I can actually keep going further back as well. So if I go cd ... and then /... that's going to go 2 folders out. So now I'll be inside the 2024 answers folder, which is where I was, which is 2 folders up from where I was before. So you can essentially go out and into folders as you want. So if I wanted to go, for example, if I go back into exercises, it'll be day 8 in this case, and then I go into the comment system, CD exercises, and then comment system, right? So now I'm in comment system. If I wanted to go to another folder that was inside exercises, I could do cd ... and then whatever the folder's called. So I think there's another one in here called upload or something like that. Yeah. So I can now go into there. So I can get to anywhere in the file system by just being able to add in these dots and adding the slashes and all that sort of stuff. I can get to anywhere I want to, which means somebody could rewrite any of the files in your system by just changing the name that they input into a file system. So here's some more advanced versions of this attack that I've linked here if you're interested in how this works. But what would we be able to do in order to avoid this problem? So I'm going to go ahead and I'll put in the top hat. Go ahead and we will start the question. So I'll give you guys a chance to answer that one. All right. So I'm glad nobody went with C. We haven't ruined everybody's day quite enough yet, so that's good. Nobody's quitting the project and moving out into the woods. The answer in this case is going to be F, which is going to be, we can sanitize the input to remove the file name. So we can remove whatever file name already exists. We can sanitize the input to remove the dot. In the case of A, we would have to give it some sort of a file name that we deem to be safe. So we could just do whatever, maybe like user's name, and then just have like a counter or something like that that we can include to just keep counting up the file names. And then D is use a file mode that doesn't override existing files. So one other thing that I didn't get a chance to mention was that with Python, there are different file modes. So if I go back to look at this, you see here we're using W+. What W+ will do is it will write and it will override anything that currently exists there. We could switch this to W, but I'm interested. Does anybody have a reason for why we might not want to do that? Why we wouldn't want to have something that why we wouldn't want to set it to something that doesn't override? Can anybody think of a reason? Give it 15 seconds and then. Nope. Okay. So one reason why we might not want to do it is because what actually happens if we don't enable overriding, right? It might be that it might just not create anything, but also it might throw an error and crash our entire site, which would also be a bad thing. You also don't want to have sites crashing all the time. So if we just left this as W and then somebody put in a file that would be overriding again, right? What we could do, what we could end up with rather, is we could end up with a situation where it tries to write something and then it actually just goes through and like crashes the whole server, and now nobody can use your site. And now if somebody wants to just like keep doing that, they can just do that as many times as they want. So sometimes you got to be careful with some of the choices you make, because sometimes your security choices can actually open up other vulnerabilities as well. Okay, so this is kind of a cool exploit that you should never use. Don't use this on anything. But one thing that you'll find is that, yeah, if there's a system that lets you name a file name, for example, so if we go ahead and I go ahead and pop this open, and then I look at, I think it's called profile1. Yep, I'll open that up. Oh, it's actually not working right now. Let me refresh. There we go. Okay. So let's say we have this file uploading system, right? So we have a bunch of files that we can upload. In this case, they're all just JPEG files, right? But let's say we know the file structure. So we have a file structure here where we can actually take a look at it. And we can see here that there's static. It's the exact same file structure that I was showing you before, where, so this is the comment system in Uploader. We have static. And then we have user uploads, right? So this is where the user uploads would go. So there would be typically a folder per user. In this case, we just have one user, right? Now, here's the problem. We also inside this have image, and this is supposed to be a protected folder where we can upload an avatar. And so when we're looking at this profile here, we can see, oh, cool. So there's an avatar there, and that avatar is just called avatar.jpg, right? Whenever we're uploading anything, we're uploading it to this user uploads folder. But if we use path expansion, what we can do is we can go from this uploads folder up one folder into the image folder and then replace the avatar.jpg with whatever we want. And so what that means is if I go ahead and choose a file, which I've already included one in here that just says I'm dumb, spelt the way it should be spelled with no B. Very important distinction there. So we have I'm dumb.jpg. And now I'm not logged in as a user on this account or whatever. It's supposed to be a protected folder, but if I just go ahead and do .. and then image/avatar.jpg. So what it's going to do is that's going to go through, and this avatar file here, we'll see if I go ahead and hit submit, I go back and I refresh. I'm in the wrong folder, so that's not going to work. Hold on. I'm in this one, and now I'm in here. Now I go back to exercises, and in here, I now go ahead and check. If I go into static, and then images, we can see here the avatar has been replaced, which means the next time that the user comes and logs in, they're going to get, I'm done. So this is a really cool attack. What you guys are going to do is you're going to go through and take a look at the code. So the code itself, let me just pull up. This is the right one. If I go ahead and just come down to the code here, we can see exactly where this is being uploaded to. So when it's coming through here, it is, which file is it? It is right here. So save the file if it exists inside there. So you're going to come through and you're just going to make sure that there's no dots or anything like that in there. So I'll give you guys a chance to try that out. And there we go. All right. So now that we've talked about a couple of different types of attacks, let's talk about some other strategies for doing securing ahead of time. So this one's nicely named, how to give strangers your credit card. And so here's a problem that I'm not sure any of you considered before, but how does your browser actually connect to a website and keep it secure? Because the one problem that you run into is that typically with any sort of security, the way that it works is you'll have some sort of an encryption key or something that you guys have agreed on. So if somebody else knows the key, then obviously they can get the information. So how do you send a message over the network to something like Amazon, for example, without having people who maybe what's called a man-in-the-middle attack, where they sit in between you and Amazon and they collect all your information, or maybe just have some software on your computer that just pulls your information and then sends it to them. So how do you actually make sure that you're kind of safe? And how do you start a connection with somebody where you're trying to have a secret, but you need to communicate in public? And so this is what we call public key exchange. And what it is basically the idea that you can exchange some information in public with each other, but you can still mathematically generate something that both of you know, but somebody else who's a third party doesn't know without the private information that each of you has. This relies on kind of some hard math. It's a little bit awful. Well, it's not that bad actually, but it's just kind of confusing for some of the math. And so there is a GitHub repo if you're interested. There's also an article on Shulkin Nights, which I'll go ahead and I'll post that link in here as well. And I'll check the article in, or sorry, I'll check the GitHub link in there as well. But essentially, if we look at this article, we can see here there's some stuff that you decide in private. So like each of these two people have picked some sort of a number in private. They exchange some stuff in public, do some math, and they both end up privately with the same number because the math only works for each of them, essentially. So you can take a look at that. The actual math itself is kind of complicated, but the thing that matters is that it actually works. And so this is called public key exchange. There's fancier versions of it that are used on sites like Cloudflare and other places that secure a lot of the web. Typically what's called elliptic curve Diffie-Hellman, which I'm not very good at math, as he's not that good at math. So if you're interested in that, you have to look somewhere else for that information. But all of these sorts of things fall under the category of what's called SSL or TLS. SSL, people will call it SSL. It's actually TLS that we use these days. We don't really use SSL as much, but SSL stands for secure socket layer. TLS stands for transport layer security, I think is what it stands for. Basically, both these things are the thing that actually will take some sort of an encryption key that you have, and it will make sure that your system is secure once you've decided on your encryption pattern. And so with public key exchanges, there's a whole bunch of different types. And so TLS will determine which type you're using, who has signed the certificate to say that it's valid, who's like done all this other stuff. And so essentially, this is a good thing to learn about. There are some places you can get free certificates. So most places will actually charge you for these, but you can actually get free ones from something called Let's Encrypt, which I should probably include in the slides next time. But Let's Encrypt is a great project that was run by a whole bunch of different companies intentionally to basically make it so that your information is more secure online. So this will let you do free certificates, essentially. And so we haven't had to worry about this because we've been using GitHub Pages, which automatically uses Let's Encrypt behind the scenes. But essentially, if you don't have SSL or TLS, every time that you fill in a form, and anytime that you send any requests over the network, like requesting certain assets or anything like that, or any resources, all of that is in fully plain text. So like we said before, HTTP is literally just text being sent back and forth between computers. So that means if you send your credit card number, if you send your email, if you send any of your passwords, anything like that, all of that, if you are using HTTP, is in plain text. So anybody who is on your network, who is able to listen to the things that you're sending across the network, will be able to basically just read all of it as plain text. It's just right there for them. They can just take whatever they want, right? And so TLS is what you would need to be able to do the key exchange in order to get the encryption key that you're both going to use. And then after you have that key exchange, there'll be some other type of encryption that'll be determined that your browser will basically determine with the website that you're talking to. And from there, it will encrypt that information with the keys that you agreed on so that nobody can actually access the information that you're looking for. And so yeah, GitHub Pages creates these for you. One other important thing, even if you're probably thinking to yourself, hey, I don't take in any data anyways. Google no longer cares. If you don't have a TLS certificate or an SSL certificate, you are no longer allowed to show up in any search results. So if you do have a website, you want to show up in search results, you have to have this no matter what. So it's always worth doing, even if you don't think you're going to necessarily get a use out of it, just because Google by default doesn't care, doesn't want to like Google. Nobody at Google is going to sit down and be like, oh yeah, we'll talk with you for the next like 5-10 minutes. We'll figure out like whether or not you actually need it, and then we'll go from there. They're just going to say, no, I don't care. Be secure or don't use our service, essentially. So make sure that you have these installed on your websites. Again, like I said, free versions. Some things, if you're doing payment, you'll need to pay for more intense certificates, and you can look into those as well if you're interested. There are 2 guides that I've included in here for how to get certificates from scratch. So how to actually use Let's Encrypt, which I've just sent in the chat, as well as how to use some services they provide that make it much easier for you to get your certificate. Okay, so next question on Top Hat is going to be, what is the main problem that public key encryption solves? That's what we've just been talking about. What's kind of the main problem that it actually solves? Go ahead and present this and start the question. So yeah, the answer for that one is B, which is publicly being able to exchange things that you can then use in private. Funnily enough, actually, I included the last one as a joke about keeping the planet warm. But one thing that I kind of love, because I think this is the most engineer thing I've ever heard in my entire life. One of the problems that you've run into with encryption is you want something to be random. And so you kind of want as much random as possible. And one thing that is super random is lava lamps. And so Cloudflare, which is the system that actually encrypts most of the web, actually literally uses lava lamps, where they have a system that monitors the lava lamps. The lava lamps go off. They have a wall of like 1,000 lava lamps, and they use that to determine a bunch of the random numbers. So if you ever thought that you've come up with a janky solution to something, this is a multi-billion-dollar company right here using lava lamps to determine their random numbers. So fun story. I love that one. But yes, they still do use these for a lot of their stuff, which is awesome. And I hope they don't change it, because that's awesome. My presenter view has disappeared on me. There we go. Okay, so we did talk a little bit about CI/CD and getting websites set up so that we can do some automation. And of course, like everything else, there's a bunch of security concerns with doing that. So one of the big things that we talked about last with CI/CD is that essentially it's executing commands, and it's executing code commands and then doing stuff automated for you. So any vulnerabilities at the CI/CD level means that you're going to be executing commands that will just be run on your behalf. So you want to be very careful, because usually CI/CD will have some sort of access that normal users won't have access to. So if people can inject commands somehow into your CI/CD pipeline, they typically will have admin access. So you want to be really careful with what you're doing. And so one thing to remember is when we talked about environments. So if you remember, these are kind of like mini computers inside of other computers. And so your operating system itself will have variables. There's a whole bunch of variables that exist on your system. So home on Unix systems, for example, is considered your like starting point from where you go. On Windows, if you go ahead and pop open a terminal, you can go ahead and you can do something like echo is a command that lets you like print stuff. So if I say echo hello, it's kind of like saying print hello, right? We'll get hello back. You can actually echo there's certain variables that exist on your system. So for example, your user profile is this path right here. So if I go ahead and I say echo, and then I use percent, and then user profile percent, this will give me my information on my system. Yes, I forgot to press N, and no, I'm not going back and redoing the entire Windows setup to add the N to the end of my name, just before there's any questions about that. So what does this mean? So this means, for example, if I want to get the desktop, I could do echo user profile percent and then slash desktop like this, and I'll get the desktop location, right? These variables are great. They're used for a ton of stuff in CI/CD, including being able to access desktops, being able to access downloads, all that sort of stuff, right? And so you can add your own. And so a lot of people will often add like secrets. And so what they'll do is they'll have some sort of a variable, like a password or something like that, which will be encrypted. And then because CI/CD systems will often create those environments one at a time, so they'll create the environment and then delete it all afterwards. People will often inject their secrets into the environment. And then because it's being deleted anyways, the password gets deleted. And then as long as it's encrypted when it's injected, you're fine. The problem is that if somebody is able to access those secrets while the environment still exists, you're kind of screwed. So what will happen is people will, it's not actually included in here, but people will do things like, for example, let's say they have a package, they get a whole bunch of people to start using it. Maybe it's something like The system that we use, for example, to upload to GitHub pages earlier is an action on GitHub Marketplace. Somebody might get a whole bunch of people to download that action, and then later on they'll add something into it where it takes your GitHub secrets and it will actually upload it to one of their servers. And they'll do that like a year after people start using it, because a whole bunch of people are already using it, and who's going to notice anyways, right? That's why that's called a supply chain attack. They're very common, where people will get a whole bunch of people to sign on to their package and then steal people's information. Another example is they'll do it with misspellings. So if you have something like, for example, Flask, somebody might have like Flesk as like a name that they register on PyPI. And then when people try to install Flask, if they accidentally hit E instead of A, now you have their package, and then they'll like run some code. So be really careful when you're setting up your CI/CD stuff. Make sure everything's spelled right. Make sure you're not downloading something that you don't want, and make sure that there's no vulnerabilities that have been disclosed. And then, yeah, also if anybody has access to your CI/CD files, they have access to your secrets. So just be careful, because they might just do something as simple as, print secret, and then they just go through your logs and just read your logs. Simple as that. Here is an example of this. I've left a video because this is a little bit more sophisticated of an attack. So if you're interested, it's called pipeline poisoning. This is a bit fancier of an attack if you are interested in stuff like that. But just keep in mind when you're dealing with CI/CD, keep everything safe. And one of the things I want to talk about as well is storing people's data. So we looked at storing content from people, but what about their actual data? So what about their passwords? What about their usernames? All that sort of stuff. So here's one thing that I would say. You should just basically anything that you see down below. So SINs, medical information, addresses, and payment information, you basically just shouldn't store. Never store it on your own servers. What I would recommend for this, and the way that you can avoid having to do this, is using third parties who are trusted. So one example of this would be if you have to take somebody's like payment records using something like Stripe. So Stripe is an online service that they'll charge you for this. But what they do is they have essentially systems where you can go through and they will take payments and they will secure everything for you. They skim money off the top, obviously, because they're running your service. But not only is storing some of this information like not a good idea, also some of it will be illegal. If you are storing people's payment information in the wrong formats, you can be charged for it, and it's a federal crime for you to do this. So I would just say any of this stuff, just keep it in mind. There's basically what are called data classifications, and everything that I've listed down below is essentially at the level of severity where you can be actively sued by people. Technically, you could be sued if you lose somebody's email address and stuff like that, but it's much harder. It's technically also a problem, but you're not going to run into as many problems. Whereas SIN, medical information, addresses, payment records, all these things have precedence in court for people being charged for leaking this information. So just be very careful about that. Phone numbers and emails you also want to be somewhat careful with as well, but sometimes it's unavoidable because you do have to have some sort of a verification method. So yeah, generally speaking, the way that I would say it is if you're going to store something, make sure you have a justification and you can do the risk reward sort of explanation, because you might have to if you do end up getting hacked sometime. You do have to tell people if you get hacked. You can't just pretend not to have been hacked, by the way, just another thing to keep in mind. So if you do ever lose people's information, you have to tell them. So don't think that you can avoid lawsuits by just not telling somebody. It's illegal to also not tell them. So you have to make sure to let people know when you lose their passwords, or if you lose their emails, or if you detect somebody has broken in, you have to tell people. So just keep that in mind. So if you do end up having to, you have to store this. Like no matter what, you have to store this. Again, like I said, you probably don't have to. You can probably find another solution to this. But let's say you do absolutely have to. Make sure to check the standards for the country that you're in and the country that you're operating in. So America will have different rules than Canada. Canada will have different rules than America. If you're operating globally, good luck. You're going to need a legal department. I'm just going to tell you this right now. It's not worth it. I have wasted years of my life doing this. It's just not worth it in any way, shape, or form. Here are some rules that you'll run into pretty commonly. So CASL, GDPR, and PCI are some pretty common ones you can find. CASL is also super important because there's a lot of common sense things that you might not have thought about, especially around email. And you can run into problems where the government can shut down your website if you're violating CASL. So things like, for example, if somebody enters their email, you oftentimes have to have an option to unsubscribe. If you don't, then you're violating CASL. Like there's rules like that you just have to keep in mind when you're making any of these things. And if you are including any of this information that you have to collect, be scanning your app. There are online tools to detect vulnerabilities. One good one is one called Snyk, so SNYK. And Snyk will basically let you do container checks. It'll let you do a whole bunch of different things. I'll post this in the chat as well. There's a ton of other services that you can use. I would just say just use as many of them as you can, just because if any of them have different vulnerabilities they're checking for, it's always good to know about any of your vulnerabilities. But do not put a website up there collect people's payment information, and then lose it because you'll run into problems down the road. So just be very careful with what you're doing. So yeah, your sneak and then deep source is another one you can take a look at. Okay. And here's another kind of way to avoid problems in the first place is by just being less predictable. So this section is not about necessarily some of the stuff will apply to backend development. Most of this stuff is about keeping you safe, essentially, online. So predictability is really bad. A lot of things that are done to break into websites actually have nothing to do with like being clever. It's not like a dude sitting at a keyboard like mashing away like 1,000 lines of code at a time. Most of the time, it's usually something obvious. It's like, hey, I Googled the guy who is the CEO of this company, and I went through and found out that his daughter's name is this, and she was born in like October. I wonder if his password is like Jamie 10, and most of the time that just is true. That's how a lot of people pick their passwords, and so then that's it. That's how they get into your system. There's no fancy genius algorithm they're using behind the scenes to break into anything. It's that they're just like, how much of a boomer do I think this person is, and how much do I think they probably have set their password this way? And that's how most actual sort of hacking stuff happens. So with that in mind, what I would say is make sure that you can try to avoid being as predictable as possible when you're doing your passwords. So there's different ways of people attacking your passwords. One of them is brute force, like I was saying before. So you go through and you say, okay, let's try the password with 1 letter. Let's try it with 2 letters, 3 letters, 4 letters, whatever. You try literally everything, right? This takes a long time. If you have 3-character passcode, it's going to take 857,000 attempts. This actually can be done really quickly. It's going to be cracked in like milliseconds, I think. Upping your character from 3 to 5 characters, you're adding orders of magnitude more amount of passwords to check. Broadly speaking, online, you want to do about a 10-character to 11-character password. It's basically, as far as I remember it, I think the time it'll take is longer than the end of the universe before they'll be able to crack it by brute force for the most part, if they're using a good algorithm on the back end. Password patterns. This is like I was saying before. If your password is predictable, it's probably already compromised. If you're doing 1, 2, 3, 4, or you're doing QWERTY, where people just hit the row of keys and just go across the keyboard, any of those sorts of things are bad, and you should feel bad. Don't make this your password. This is not a good password. Don't do this, please. Try to avoid using your name. Try to avoid using your dog's name. Try to avoid using like your mom's name. Don't use people's names. Don't use people's birthdays if you can. Avoid that as well. And don't use like some celebrity. Don't use like Leonardo DiCaprio 24 as like your password or something like that. Like don't do anything like this. Don't do stuff that's really obvious. What you can do, there's a bunch of different rules that people can do. So here's kind of the rules that most things check. So the first last name of somebody who it is, or both. The birth year, birth month, birthday of a self or a relative, pet names, current year, or the sign up year. So people will often put like, they sign up for a website and it's Facebook and their password will be Facebook 2023. And it's like, that's a good idea. Child names, child birthdays, parent names, parent birthdays, anything like this, anything that's super obvious that people can find out about you by just looking. Don't use it in your password. It's just not going to go well. So how do you actually do this like well? How do you make sure to how do you like keep people from doing this on the development side, right? First of all, don't let them use the name they signed up for in the password. This is a super easy check. Just literally check if the name they're signing up for, like if Kieran is in the password, you're not allowed to do it. Like, no, put a message up there and just like call them out for it. Get angry about it. Send them a link to a URL. Just don't let them use any of the names that are available in the passwords. Don't let them use like something obvious. There's a bunch of passwords you can check for. Like password is the easiest one. Just don't let them use password. It's very easy. If somebody wants to use password, too bad. Don't let them do it. And then force at least one symbol. This is one thing that people will get annoyed by, but symbols are actually super useful because symbols are the least likely to be put at the end of a password. If you ask somebody for a number, they'll pretty much always put it at the end of a password, but people often with symbols will put the symbol first or last or in any place in between. So when people are trying to scan passwords, it's actually harder for them to find symbols than it is for them to find numbers because they're less common. So just keep that in mind. Okay, last question of today, which is going to be, why is predictability bad based on everything that we've talked about so far? So pop this open, and there you go. Yeah, so that one just E, which is A and D in this case. There we go. Okay. So I believe this is the last one. Yeah, it's in here. So IDs. So this is the last thing that I want to talk about. Well, one of the last things I want to talk about because it comes up a lot. One easy way that people will make a lot of systems is you might have something like a profile, and you have somebody's profile, and when they sign up, let's say they're the first person, their profile, you go to yourwebsite.com/profile/1, and that might be like the first user who signed up for your profile. Second user is 2, third user is 3, right? Most of the time, this is fine. Doesn't really matter that much. There's actually some websites right now that exist where you can actually see it, like that sort of pattern existing, but it can be dangerous. So yeah, start from 0, go up from there. So as you go through, you get to 10 people on the server, you can go to like /user/4 to get like the 4th user, right? So a couple of issues with this. One of the main ones being that as search engines and a bunch of other stuff have gotten more popular, there's a lot of people who are just scraping websites for random bits of information just to scrape the website for information. If your site gets more popular, this can waste a lot of your resources. So if somebody, for example, can just go through and find every one of your users, they will just go through and look for every single one of your users, right? It'll just waste a whole bunch of your time and a whole bunch of your resources on your computer, waiting for all these things to process. And so you sometimes want to enforce some randomness so that you don't get people who are just randomly scraping a bunch of information. One other really dangerous one that I have seen was there was a screenshot utility in 2010 that I used to use called Print Screen. And this used to use random number generation to do its system, but it was very predictable. It was always 4 numbers. And so there were multiple times where even I just for a laugh tried it at one point, where you might type in like print screen, I think it was like prnt.sc, SCRN or something like that. And then it's like / and then 4 numbers. And I just put in random numbers and I ended up with somebody's bank details in like 3 attempts. So because they were just uploading people's screenshots, you could just find it however you want to do. If you forget to secure a route, people can steal data. So if you forget to secure like somebody's like checkout page, for example, you might leak their address. Don't worry about this one. This one's just more complicated. If you know what it means, then it's important, but don't worry about it if not. It's very easy to accidentally override entries. Let's say, for example, you're counting from 1 to 10. Let's say, for example, you delete a user and all you're doing is checking the amount of users that previously existed. Once you delete a user, it will reset the counter back 1, and now you'll override the last person in the list. So be very careful about that. And it's also very boring. Why would you want to do this? It's just kind of boring. So what other options exist? The main one is what's called a UUID. This is the one that everybody uses. And essentially what it does is it's unique. So import UUID. In Python, you can do it with UUID.4, and crypto.randomuid will work on JavaScript. These will generate random IDs for you that will work for everything, essentially. There are 2 other types of attacks that I've listed in here. So there's caches, which is basically a fancy system that will essentially is used to store information. And then people will use this to avoid having to do some extra processing stuff. If you're interested in how this works, there is a blog post somewhere here. Caching is somewhere. I swear. It is. There it is. So if you are interested, there's a blog post about how this works and what it is. But basically, there are ways that you can get people to store information that's invalid and then continuously re-deliver that to people. So if you're interested, you can see that article and that will give you an idea of what that looks like. Again, like I said, some attacks aren't meant to be immediately. So this oftentimes caches, the thing with them is they're a bit weird, and sometimes they'll activate after a certain amount of time. So you want to be careful when you're doing caches, not to activate it after a certain amount of time if you're not going to scan the caches for information, because you might end up accidentally like deploying stuff that you didn't want to. And the very, very last thing that I'm going to cover for the whole set of sessions is social engineering. This basically is that the weakest link in everything is always people. So whenever you're doing any security, don't just rely on, here's my admin, he'll make sure it's going to be safe, or she'll make sure it's going to be safe or whatever. Please make sure that you have safeguards in place, even for the people who are like the admins there, because what you can find is somebody will like call into a call center. Let's say, for example, you're securing your system by email. They'll call Google and then ask for a password reset and then try and convince the person on the other end of the phone that they're the person who owns the account, and they'll get all the information and stuff like that. So you just want to be really careful. 2FA is a good idea. This basically means that you have to have more than one method to log in. You might need a password and a phone code or an email, something like that. There's systems online for you to be able to implement this. OAuth is one that you can Google that will let you basically be able to set this up easily, so you don't have to deal with it yourself. And session jacking, This is more complicated, but basically sometimes instead of passwords, people will be given tokens by companies. So when you sign in, it'll give you a token. That token can be used. Here is a recent example. I'll share this link in the chat as well if people are interested, from a channel called Linus Tech Tips that had this happen, where they basically had their YouTube account stolen for a little while because of this. Essentially, the person somebody logged into their account, installed somebody's extension, and then when they logged into the account, it sent that token to the person who was trying to steal their account, and then they were able to get into the person's account. So super dangerous. Ignore that. That was from last time. That is also from last time as well. So the actual gala information is, I believe it's on the December 22nd, and the registration is available from last week's slides. So I can go ahead and grab that link for people who are interested. But yeah, that'll be a good chance if you want to earn some extra Ignite points. Then you can go ahead and check that out. If you have a project that you want to do to be able to show off to people, this is a great place to also meet people who are in industry. You can get a head start on learning more about kind of the software development world. If you're interested, I have just linked the registration in chat for the gala. It is the 22nd from 6 to 8 p.m. And I just want to thank everybody who is still here and everybody who came throughout the sessions for showing up. I know this one took a little bit longer to get through, but hopefully it was good. And if you guys enjoyed it, then yeah, that's great to hear. Everybody who isn't a mentor, you can feel free to take off. For mentors, we're going to do a quick debrief. So go ahead and stop my share. And I'll stop the recording.